Okay, morning everyone. So we're going to continue today. Just before we end the session today, I will give you some important information concerning your midterm exam, right? So stay tuned for that. Hopefully more people might come on the call during the course of the class, right? So I just want to continue some of the lecture that we were going through up to a certain point and then continue with some of the questions we were looking at last day. Right, so this is one of the examples here from the lecture notes, right? Which is one of the examples I believe we went through, right? So let's just revisit it again because the last example I did in the lecture notes was this one here on page 63. Right, so this one here, 43.5 in the finance. Use the definition of the Laplace transform to show that L of t minus 5 is 1 over s squared minus 5 over s for real s greater than 0. So basically, you just take the definition of the Laplace, which is the integral between infinity and 0, e to the minus st t minus 5, because your function is t minus 5, right? And then you take the limit as r tends to infinity, and you change the upper limit to r, the lower limit remains at 0, and then you do the integration by parts here. So of course, you have v as t minus 5, right? So dv will, you're differentiating here, sorry, with respect to t. So the constant 5 will drop out, so you get dv is dt, right? And then you have du is e to the minus st dt. So if you integrate this with respect to t, you'll get minus e to the minus st over s, which we quite familiar with because it's something being repeated a lot in a lot of the problems, right? So now you're taking the limit as r tends to infinity, uv, which is t minus 5 by minus e to the minus st over s, which is what you have here in the square brackets. And your limits here will be r and 0, right? And then you're taking v du, right, which is this here, right? So you have minus e to the minus st over s, so you're minusing that. So a minus minus would be a plus. So you could pull out the 1 over s on the outside here, and then you take the limit, the integral, sorry, between r and 0 of e to the minus st dt. And this here now, as r, you replace the upper limit with r here, right? And then you replace the minus minus, the lower limit would be e to the 0 minus minus e to the 0 minus 5 over 5. E to the 0 is 1. And you'll have 1 here, so you'll have minus 1, right? And then you take this here, the integral here of e to the minus st dt, which is e to the minus st over another s minus s. So you end up with a s squared in the bottom here with a negative in front. And you take the limits here as r approaches infinity, the upper and the lower limit as r and 0. Right? So this here now, the two terms from the first part will give you this here, minus 5 over 5, which is 1. And this part here as r approaches infinity this exponent is negative. So this will approach 0, right? And then at the bottom here now, you'll have minus e to the 0 over s squared, which is 1 over s squared. And the upper limit now minus e to the minus SR over s squared. And this also here, this term here will also approach 0, right? So these two terms here will drop off, right? Right, so we write them, separate them out because the R within these two terms here, right? And then we have the two terms without the R at the front, 1 over s squared minus 5 over s, right? I said 5 over 5 here, but sorry, it's 5 over s, right? And then you have the two terms here, including the limit, right? You put the e to the minus SR at the bottom, similarly here. So all these two parts here will approach 0. So you'll get 1 over s squared minus 5 over s when s, real s is greater than 0. Right? Problem 44.11, page 25 in the finance. Ft is h at t minus 1 plus h at t minus 3. So the heavy side here plus another heavy side, right? So to answer this question here, you want to find the Laplace of Ft. So you're breaking up. We know that h at t minus 1 will be when t is between 0 and 1, that this heavy side here will be 0. And anything beyond 1, this will be 1, right? The other function on the other hand here, this one, the heavy side at t minus 3. Anything between 0 and 3, this will be 0, and it's only when it's greater or equal to 3, it will be 1. So in this region here, the heavy side at t minus 1, the heavy side at t minus 3 would both be 0 when t is between 0 and 1. H at t minus 1 will be 1 between 1 and 3, but h at t minus 3 will be 0 there. And both of them will be 1 when t is greater or equal to 3. Right? So if you add these two functions here from the table here, 0 plus 0 is 0, 1 plus 0 is 1, and 1 plus 1 is 2, right? So therefore we could graph the function, right? So between 0 and 1, the function is 0. Look at here. Your line on the t-axis, right? And you have an open circle here at 1, and then a closed circle, right? Because between 1 and 3, the function jumps up to 1. So at the left hand end, you have a bold circle, a shaded circle, and an open circle because it doesn't include 3, right? And then it jumps up further to 2 then, between 3 and beyond 3, as a matter of fact, all the way to infinity. So you have a shaded circle here, and then the line just continues, right? And of course, the Laplace of Ft would be the Laplace of Ht minus 1 plus the Laplace of Ht minus 3, which is e to the minus s over s plus e to the minus 3s over s. So this other example here from Finan as well, 44.17, right? So I have this piecewise function here, right? So what I did here, I defined the various regions because they say represent Ft as a combination of heaviside functions and determine the Laplace of Ft. So this part here, I wrote it in, right, with the functions and so on, f1, t, f2, t, f3, t, and f4t. So if you give me a graph with a piecewise function, it might be a wise thing to do that in order to break it up to see how you could expand it into a combination of Heaviside functions so that you could find the Laplace transform. So anytime there is a Q, anytime you have a problem involving a piecewise function, right, you have to break it up as a combination of Heaviside functions in order to solve it. Right, so you understand that? I hope that is clear. Right, so anything you're doing, if it's a differential equation, initial value problem, right, and it involves a piecewise on the right-hand side of the initial value problem, or the differential equation as a matter of fact, that function, once it's piecewise, you have to break it up into the combination of Heaviside functions in order to find the Laplace. So the first part of the graph is on the t-axis, so that means the first function we define it to be 0. Then the second function, right, is on, it has a positive slope, right? It starts at 2 and it ends at 3. So if you look at the slope here, from here to here is 1, and from here to here is 1. Right, so the rise over the run is 1, so which means the gradient here is 1. So you have t, because the value in front t is 1, and then the y-intercept will be -2. The y-intercept will be down here, right? If you continue, you come down here, 1 and 1. So you could form little triangles here, and then 1 and 1. So here it will be -1 and -2. So I mean, by just looking at that, you could plot it and you could see where the y-intercept would be. So this is the function t -2. The third part of the graph, f3t, the graph is 1, right? And then the fourth part here, the graph is 0. So obviously, if we're breaking up this here into a combination of Heaviside function, this part here, f1t and f4t, won't give you anything. The focus would be on the two middle parts here, f2t and f3t. Right, so look at the piecewise function here. So between 0 and 2 is 0, between 2 and 3 is t -1, sorry, t -2, between 3 and 4 is 1, and between 4 and infinity, the function is 0, right? So I mean, just for completeness here, it's written out. So in this first piece here of the function here, between 0 and 2, right, you have to take 1 minus the Heaviside 2, t -2 by 0. And then the second part would be the Heaviside at t -2 minus the Heaviside at t -3 by t -1. And then the third part here now will be the Heaviside at t -3 minus the Heaviside at t -4 by 1. You're multiplying it by the function. And then finally the Heaviside at t -4 by 0. So I don't cross out the two parts here that won't give any contribution, right? This part here with the t -4 is really h to the t, the Heaviside at t -4 minus the Heaviside at t infinity. And you know the Heaviside at t infinity is 0. So what we have would be this part here, h at t -2 by t -2. And h at t -3 by t -2. And then you have h at, well, here you could write this as 2 minus 1 here, because you'll get t -3 here. So when you expand this out, and then of course this part here, right? From this part here, you're getting your t minus 3, right? Plus h at t minus 3, which is what you'll get here when you multiply the minus ht minus 3 by 1. And then finally, you'll have h at t minus 4. So now, if we expand it out here and we simplify it, we'll have h at t minus 2 by t minus 2, h at t minus 3 by t minus 3 from this part here, and then h at t minus 4. And of course, we could take the Laplace of that. That would be e to the minus 2s over s squared minus e to the minus 3s over s squared. And this part is just the heavy side. So it's just the Laplace of a heavy side, which is e to the minus 4s here, because your t naught is 4 over s. Right? And that gives you the Laplace of the piecewise function here that we had to write as a combination of heavy side functions. Right? So this is the point at which we would stop in order for the coursework exam. Now the next part here, which is the delta Dirac function, Dirac delta function, right? This part here we will deal with it, right? But this up to here wouldn't come in your midterm exam. So all the way up to page 67, everything that was done prior and up to this point here would be coming in your midterm exam. Right? So let me just go back to some of the questions that we were doing last week. Right? Right. So I think we stopped at page 19. And that was the problem that we did here, right? 44.17, the same problem, right? 44.21, right? So let me just let me just stop for a minute so you could collect your thoughts, and if you have anything to ask, you could do so. Okay, nothing so far. All right, so let's go back to the okay, so use the Laplace transform technique to solve the initial value problem. Right, so you have y prime plus 4y equal gt. And we have our initial condition here, y0 to be 2. And gt is piecewise. So it's defined to be 0 between 0 and 1, when t is between 0 and 1, 12 when t is between 1 and 3, and when t is greater than or equal to 3 to be 0. Right? So of course we had to break it up into combination of heavy side functions, your gt. Right? So that is what we're doing here. Well, this one here, that is the first part of the function here. You have to multiply it by 0. The second part, you're multiplying it by 12, which is h at t minus 1 minus h at t minus 3 by 12. And then the third part will be h at t minus 3 minus h at t minus infinity, which is, 0 by 0. So this, the first and the third part won't give any contribution. So it's just the second part. So you will end up getting 12 h at t minus 1 minus 12 h at t minus 3 And the Laplace of this now, the right-hand side, is 12 e to the minus s over s minus 12 e to the minus 3s over s for s greater than 0. Right? Right. So now you want to take the Laplace transform of the differential equation and use the linearity property. So you're taking the Laplace transform of the left-hand side now. We already did it for the right-hand side. Right? So Ly prime is sys minus y naught plus 4ys. And this part here, 12 into e to the minus s minus e to the minus 3s over s. Right? And now you substitute your initial condition, which is y naught to be 2. Right? So you have sys minus 2 plus 4ys. So I just rewrite it. I put the 4ys in front and the minus 2 here on the right. And you have 12 e to the minus s minus e to the minus 3s over s on the right. Right? So on the left here, you could factor the ys and you carry the 2 across. So you'll have 2 plus 12 e to the minus s minus e to the minus 3s over s. So therefore ys you have to divide throughout on the right hand side by s plus 4. So you'll end up with 2 over s plus 4 plus 12 e to the minus s minus e to the minus 3s over s into s plus 4. Right? So this part here, the Laplace, the first rational fraction here is straightforward. We could do this. But the second part now is a little complicated. So you have to break up this into partial fractions, right? Right? So what you do here, the part with the e to the minus s and the e to the minus 3s cannot be part of the partial fraction. So you just take 1 over s into s plus 4, right? And then after we will multiply it by the 12 e to the minus s, right? This should have a bracket around it, right? As well as this. So when we break up 1 over s into s plus 4 into partial fraction, you'll end up with a over s and you'll plus b over s plus 4 because these are two simple factors. And when you solve for a and b, right, you will get a to be a quarter and b to be minus a quarter. So look at root it here. A quarter over 1 over s minus a quarter by 1 over s plus 4, right? Right. But remember now, the top must be multiplied by 12 e to the minus s minus e to the minus 3s. So we have to cater for that now. So what I did here, the 4 is common to 1 over s and 1 over s plus 4. So I pull out the 4, right? And remember I have a 12 here, so I pull out the 4 and I have 12 over 4. And then I have to multiply the partial fraction here that we decompose by e to the minus s minus e to the minus 3s. So this here will give me 3, right? So look at the breakdown here, right? So you have 12 into e to the minus s minus e to the minus 3s over s into s plus 4, right? So the 12 over 4 I got here on the outside works out to be 3. So the Laplace inverse of e to the minus s minus e to the minus 3s multiplied by 1 over s minus 1 over s plus 4, right? And then when I expand that, I will get these 4 terms here, right? So I'll get 3 by e to the minus s over s, right? Minus 3 the Laplace inverse of e to the minus 3s over s, and then I'll get minus 3 the Laplace inverse of e to the minus s over s plus 4, and finally I'll get, when I multiply the last two terms here, minus by a minus is plus, so I'll get 3 the Laplace inverse e to the minus 3s over s plus 4. Right, so when we deal with each one of these here individually, it's much easier to see. So you have e to the minus s over s, the Laplace of that is h t minus 1, right? So you have your 3 on the outside, then the Laplace inverse of the other one is minus 3 by the heavy side at t minus 3. And then the third one here, right? So this involves e to the minus, so your t here, your t naught is 1. And then you remember this part here, s plus 4. So you have to apply the shift here, right? So you have, sorry, you're applying the Laplace inverse, right? So you have e to the minus t naught by s, and then this is 1 over s plus 4, which is the Laplace of 1 over s plus 4 is e to the minus 4, right? But when you have a heavy side and a function, right, you have to replace your minus 4t by your t minus 1, because your t naught here is 1. So that is minus 3 e to the minus 4t minus 1 by the heavy side at t minus 1. And then the last part, same thing by the third part. So e to the minus 4 t minus 3 by the heavy side at t minus 3. So basically the e to the minus 4 by the t minus 3 is your function, right? Your function of t minus your t naught. And your t naught here is 3, right? So this gives us the Laplace inverse of this part here. So when you combine all the parts together, right? The first part, you need to find the Laplace inverse at 2 over s plus 4, right? And then you got this part here from what we did here. Plus 3 the heavy side at t minus 1, minus 3 the heavy side at t minus 3, minus 3 e to the minus 4 into t minus 1 h t minus 1, plus 3 e to the minus 4 into t minus 3 by h t minus 3. So this part here, the first one that we needed to find, this will be 2 e to the minus 4t plus 3 h t minus 1 minus 3 h t minus 3 minus 3 e to the minus 4t minus 1 h t minus 3 plus 3 e to the minus 4t minus 3 by h t minus 3. And t, your variable t is greater or equal to 0. Right, so that is how you do it there. Right, so look at it carefully. Right, and the most difficult part is this part here, the last part here. Right, to break up into partial fraction is not difficult, but then when you're combining, when you're multiplying the top, you have to be careful. You have to break it up into the 4 functions here that you're taking the Laplace inverse of individually, right? And then collecting all the terms and writing yt. Use Laplace transform technique to solve the initial value problem. So we have another one here, right? This one doesn't involve a heavy side function, or a piecewise function rather, that you will have to write as a combination of heavy side function. So this one here, a second order differential equation, the initial values here, y naught is 0 and y prime naught is 0. Taking the Laplace transform of the differential equation and using the linearity property, you take the Laplace transform of y double prime minus 4 times the Laplace transform of y equal to the Laplace transform of e to the 3t. So here now, the Laplace transform of y double prime, and remember this double prime here is a function of t, right? So in the final, they don't have t, right? But when you write in your notation, always put in the t, right? So this here will be s squared ys minus sy naught minus y prime 0, and then minus 4ys. And we know that these two terms here would be 0. This is 0 and 0. So you'll just get s squared minus 4 into ys is equal to 1 over s minus 3. So ys is 1 over s squared minus 4s minus 3. Right? So this is the difference at 2 squared. So you could break up that into two simple factors. 1 over s plus 2s minus 2, s minus 3. And that is easy to break up into partial fractions. That'll just be a over s plus 2 plus b over s minus 2 plus c over s minus 3. And when you multiply it throughout by s minus 2, s minus 3, and s plus 2, you will get 1 is equal to a into s minus 2 into s minus 3 plus b into s plus 2 into s minus 3 plus c into s plus 2 into s minus 2. Right, and if you put s equal to 2, of course, this term here and this last one here will vanish. That will be 0. So you'll have 4 here by minus 1 and minus 4b is 1. So b is minus a quarter. If you put s equal to 3, the first term and the second term will drop out. So you get 3 and 2 is 5. By 1 is 5c is 1. So c is a fifth. And if you put s equal minus 2, the second and the third terms will vanish. So you get minus 4 by minus 5 is plus 20. A is 1. So a is 1 over 20. Right? I hope you've seen that, right? So now we taking the Laplace inverse of that entire fraction, which was broken up into a is 1 over 20, L inverse of 1 over s plus 2, and then the b part is minus a quarter, L inverse of 1 over 1 over s minus 2, and then the c part is 1/5. So you're adding 1/5. The Laplace inverse of 1 over s minus 3, which is 1 over 20 e to the minus 2t minus a quarter e to the 2t plus 1/5 e to the 3t for t greater or equal to 0. Right. So 45.5, we taking the Laplace inverse of 1 over s plus 1 in bracket cube, right? So we considering, right? We considering here the Laplace inverse of 1 over s cube, right? And we know that the Laplace inverse of 1 over s cube is really a half into the Laplace inverse of 2 over s cube, which is a half t squared, right? So therefore, we could apply the shift property here, the Laplace inverse of y s minus a, right, is equal to e to the at, the Laplace inverse of sy. So your sy here will be this part here, right, the 1 over s cube. So therefore, the Laplace inverse of 1 over s plus 1 cube right? Because remember your shift here will be -1, so that is e to the minus, your a here is your -1, because if you have a minus a here, s minus a minus will give you a plus, right? So you have your power here is minus t. You have your half in front. That is how we scale it here. And then you have t squared. So t greater or equal to 0. So sometimes it's be helpful when you're doing these problems to write down the rules while you're working through it, so you will see how it unfolding as you go along. And it'll be easier for you to do it. (45.6). Find the Laplace inverse of 2s minus 3 over s squared minus 3s plus 2. Right, so before we could find the Laplace inverse, we had to find the partial fraction breakdown of this rational fraction. So if we look at the denominator, we could factorize it into s minus 2, s minus 1. So 2s minus 3 over s minus 2, s minus 1 is equal to a over s minus 2 plus b over s minus 1. Right, and if we multiply throughout here by s minus 2, s minus 1, we'll get 2s minus 3 is a into s minus 1 plus b into s minus 2. If we put s equal 1, we'll get minus b is minus 1, so b is 1. If we put s equal to 2, we'll get a is equal to 1. 2 2's are 4 minus 3 is 1. So both a and b here are 1. So you're taking the Laplace inverse of 1 over s minus 2 minus the Laplace inverse of 1 over s minus 1, which is e to the 2t minus e to the t for t greater or equal to 0. Anything on that so far? Right, okay. Okay, so 45.8. The Laplace inverse of s squared plus 6s plus 9, sorry, plus 8 over s to the power 4 plus 8s squared plus 16. Right, so if you notice here, this denominator here is a perfect square, right? So you could factorize the denominator into s squared plus 4 in bracket squared. So you have s squared plus 6s plus 8 on the top, and s squared plus 4 squared at the bottom, right? So this factor here at the bottom here is quadratic, so which means the partial fraction breakdown will be, right, it's quadratic and it repeated because you have a square here. So you have to write as plus b over s squared plus 4 and cs plus d over s squared plus 4 squared. And the usual step here, you multiply throughout, right, by s squared plus 4 squared, right? So if you multiply throughout by s squared plus 4 squared, you will get s squared plus 6s plus 8. One of the s squared plus 4 will cancel, so you'll get as plus b into s squared plus 4. And here it will cancel, so you'll just get cs plus d, right? And what I did here is I expanded out all the terms here and I collect coefficients, right, in order to do equating. So when I do that here, I'll get as cubed plus bs squared plus 4as, right, plus 4b plus cs plus d. So now I'm collecting all the terms in front, s cubed. So here is a, here is b, here will be 4a plus c, and then you have 4b plus d. So on the left-hand side, you have no s cubed. So which means the coefficient of s cubed is 0, right? So a is 0. You have a coefficient of s squared, right? The coefficient on the left-hand side is 1 because you have s squared, so b is 1. C no, sorry, coefficient, the coefficient of s. So 4a plus c. And then on this side here, the coefficient of s is 6. So 4a plus c is 6. We know a is 0, so c had to be 6. And then finally, the coefficient of s to the power 0, which is a constant. So 4b plus d will be 8. So d would be 8 minus 4b, and you know that b is 1, so 8 minus 4 is 4. So we have all our values there now, right? So a is 0, b is 1. So in the first instance here, this first fraction here, again, 1 over s squared plus 4. You see that here? And then the second instance here, again, cs plus d over s squared plus 4 squared. C is 6 and d is 4. So that is 6s plus 4 over s squared plus 4 all squared. So you need to find the Laplace inverse of these two rational fraction. So this one here, and then the second one here, you could break it up into 6 by the Laplace inverse of s over s squared plus 4 squared, and then plus 4, the Laplace inverse of 1 over s squared plus 4 all squared. Right. So this one here is straightforward, right? Because the Laplace inverse of 1 over s squared plus 4 could be written as this. And then you have to multiply on the outside by a half. Right? So that is how I break up this here in order to find the Laplace inverse. Right? So this inverse here is sine 2t. So you have to multiply it by your half here. So that is what you got here. A half sine 2t. This one here, Laplace inverse of s over s squared plus 4 squared. Right? This one here is a little more complicated. So you have to use this theorem here called the Convolution Theorem. Right? So how you go about using this theorem here? So I have it written down here. Right? So you break up the Laplace inverse of s over s squared plus 4 squared into s over s squared plus 4 by 1 over s squared plus 4. So s over s squared plus 4 by 1 over s squared plus 4. When you multiply, obviously, you'll get back this here. And you call one of the functions ys, and you could call the other one gs. So your ys is s squared plus 4, and your gs is 1 over s squared plus 4. Of course, your inverse Laplace of ys here, which is yt, for this first function here in your product, would be cos 2t. And the inverse for this one here is what we got initially. So your gt here is a half sine 2t. Right? And this is how the theory is applied here. Now the reason why I put 6 here is because we have to multiply by 6 here. Right? So remember that. So this is here, your y by a g of t, so that is these two functions here, is equal to the integral between t and 0, right? Cos 2, wherever you see a t here, you replace it by t minus u. So your variable here, t becomes t minus u. So you have cos, right? Cos 2t will be cos 2 into t minus u. And then the other function, your t changes to u. So the first function, your t changes to t minus u, and then the second function, it changes to u. So you have here now multiply by half sine 2u du. So remember you're integrating here with respect to u now, eh? And the reason why I put this 6 on the outside is because I have to multiply by 6. So if you look at this carefully, you have a 1 over 2 here, you could pull out that on the outside. So that will be 6 over 2, which is 3. And you'll have this integral here, cos 2t minus u sine 2u du, right? So here now you could use this identity here, sine A cos B, right? Is equal to sine A plus B plus sine A minus B over 2. So you break up this here into that form. So I just write in it here, sine 2u will be a A. So your A being replaced by this, and your B being replaced by this whole thing here, right? So would be sine 2u plus 2t minus 2u plus sine 2u minus this. So that will be minus 2t plus 2u. And if you simplify this here, of course, you'll get sine 2t. And you'll get sine 4u minus 2t over 2. Right? So remember you have a 2 here in the denominator. So you're breaking up this here into this down here. Using your trigonometric formulas. Right? So what would happen here now? You'll have a further 2 in the denominator to carry out here. Remember this works out to 3. So when you have a 2 to carry out, you'll get 3 over 2 in the denominator. And then you're taking the integral of sine 4u minus 2t plus sine 2t du. So you're integrating 2 terms in sine with respect to u. So when you're integrating sine, what you just get? Right? You just get minus cos. So you get minus cos 4u minus 2t. And then you have to divide by the coefficient of the u here because you're integrating with respect to u, right? So you divide by the 4. So you remember you're dividing by the 4 here, not this here because you're treating this as a constant. You're not differentiating, rather you're not integrating with respect to t but to u. So you're ignoring this part here, just the 4 here in front of the u there. So you'll get minus cos 4u minus 2t over 4. And then this term here, the sine 2t, you're integrating this with respect to u. So this whole thing here is a constant because this sine is in terms of t. So all you have to do is add a u in front of it plus u sine 2t. And then you're taking this in, after you integrate here, you're taking the limit here, the upper and the lower limit to be t and 0, which we had to do here. Right. Remember, you have 3 over 2 on the outside. So now, all you have to do is plug in t, where u is. Because you remember, you integrated with respect to u. So that will be 4t minus 2t. So you'll get minus cos 2t over 4. And then you do the same thing here. So where the u is, you put t. So that is plus t sine 2t. And then you're minusing this here now when you put in 0. So that will be minus minus, which is plus cos minus 2t over 4. but minus 2t. Cos of a negative is the same as cos of the positive. You can remember cos is an even function. So cos of negative 2t is the same as cos of 2t. That is why I write cos of 2t over 4. And then you have to minus this term here with 0. So obviously this, if you multiply by 0, you get 0, so you minus 0 here. And notice the first and the third term will cancel each other. So you'll just get t sine 2t, and you have to multiply that by 3 over 2t. Sorry, you have to multiply it by 3 over 2 on the outside, so you get 3 over 2t by sine 2t. Right, so I hope that I went through it slow enough for you to see. Right, so you have to work through it gradually. Right, the second part now, similarly, right? So we want this part here as well, right? We want to break up this into 1 over s squared plus 4 by 1 over s squared plus 4. So that is why I say similarly for the Laplace inverse of 1 over s squared plus 4 squared could be broken up like this here. 1 over s squared plus 4 by 1 over s squared plus 4. This is your ys, 1 over s squared plus 4, and your gs is 1 over s squared plus 4. So your integral of this function, sorry, your Laplace inverse of 1 over s squared plus 4 will be a half sine 2t. And similarly, this is the same thing here. So your gt here will be a half sine 2t. But when you're writing it now in the form, the convolution, as the integral of these two functions, y and g, right? Remember, you have to multiply by 4, hence the reason I put the 4 on the outside of the integral and outside on the left here, right? So now this here, remember, you replace the t here now by t minus u. So that will be sine 2t minus u over 2. And this is going to be sine 2u. You replace the t here by u over 2. Because that caters to the half. And then 2 by 2 is 4. So you could pull that on the outside. 4 over 4 is 1. So you have the integral here, sine 2 into t minus u by sine 2u du. Right? And then you could use this identity here. Sine A sine B is cos A minus B minus cos A plus B over 2. Right? So the 1 over 2, you pull it on the outside. So, of course, here A will be 2t minus 2u, right? And your minus in 2u, that is your b. And then a plus b would be this, 2t minus 2u plus 2u. So you'll get here in the second term here, the 2u's will cancel each other, the plus and the minus, so you'll get cos 2t. And here now you'll get cos 2t minus 4u. And then you just integrate this here with respect to u, right? So that will be the integral of cos is sine. So that will be sine 2t, and you divide by the constant in front of the u here, which is minus 4. And then you integrate in this with respect to u. This does not have u in it, so you treat it as a constant. So that will be minus u cos 2t. And then you apply your limits here. So when u is t, right, you'll get sine minus 2t over minus 4 minus t cos 2t. And then you have to minus, so that will be plus when you're adding the 0. So that will be plus 2t over 4 plus 0, right? Or minus 0, because the u part there multiplied by the 2t will give you 0, right? Now remember, sine is an odd function. So this this sine minus 2t is really minus sine 2t. And then you have a minus underneath here to kita for a minus and a minus 4. So this term here will actually be sine 2t over 4. And then you have another sine 2t over 4. And then you have the minus t cos 2t. So a quarter and a quarter is a half. So a half sine 2t minus t cos 2t. And then you remember you have a half on the outside. So you'll get a quarter sine 2t minus a half t cos 2t. Right? So now you're collecting all the results. Right? So the first Laplace transform, the Laplace inverse of the first part here was a half sine 2t. Remember this one here with the 6 Laplace inverse of s over s squared plus 4 all squared here. This one was 3 over 2t sine 2t. And then the 4, the Laplace inverse of 1 over s squared plus 4 squared is what we got here. A quarter sine 2t minus a half t cos 2t. Right? So now, I mean, we could simplify this here, right? So we could say that this is, these two terms are like, so you could say this is 3/4 sine 2t, because a half and a quarter is 3/4 plus 3 over 2 t sine 2t minus a half t cos 2t. For t greater or equal to 0. Right. Right. So I hope that gives you some light on how to find the Laplace transform. There isn't any straightforward rule when you're dealing with a inverse transform for something like this here, where you have a power s squared plus 4, something like a quadratic factor that repeated or raised to a power like this. There's no straightforward rule to find the Laplace inverse. That is why you have to break it up into using the convolution theorem. So let's look at some further problems here. Right? Use the Laplace transform to solve the initial value problem. So you have a first order differential equation here. Y prime plus 2y is equal to 26 sine 3t. And your initial condition here is y0 is 3. So you first of all, you take the Laplace transform on the left hand and right hand side of the differential equation. So you do the Laplace of y prime is sys minus y naught plus 2is is equal to 26. The Laplace of sine 3t is 3 over s squared plus 3 squared. So this left hand side here, remember the y naught is 3. So that will be sys minus 3 plus 2 ys. And this 26 by 3 is 78. 3 squared is 9 in the denominator here. So the 3 you could carry it on the right hand side, so you'll end up with s plus 2 in bracket of ys is 3 plus 78 over s squared plus 9. When you divide the right-hand side by s plus 2, you'll end up getting ys is 3 over s plus 2 plus 78 over s plus 2 into s squared plus 9. And then you have to use partial fractions to simplify this part here, right? So here now, remember the 78 over s plus 2, s squared plus 9 could be written like this. Right? 78 over s plus 2, s squared plus 9 is equal to a over s plus 2 plus bs plus c over s squared plus 9. And then you multiply it throughout by s plus 2, s squared plus 9. What that will give you? That will give you a into s squared plus 9 plus bs plus c into s plus 2. And then if you equate coefficients, right? The coefficient of s squared is a plus b. And on the left-hand side, the coefficient of s squared is 0. So a plus b is 0. The coefficient of s is ab plus c. And on the left-hand side, the coefficient of s is 0. So you have you have 2b plus c is equal to 0. And finally, the coefficient of s to the 0, which is the constant on the right, 9a plus 2c, right? And the coefficient on the left-hand side is, well, initially we had it as 1, right? So let me just make some slight changes here to make it a bit easier. I want to work with the 78. So this, to keep this consistent, keep this as 1, right? So therefore, a plus b is 0, b is minus a from 1, and from 3 now. So we could solve these 3 equations here. C is 1 minus 9a over 2. Substitute b equal minus a, and c equal 1 minus 9a over 2 into 2. So you get minus 2a plus 1 minus 9a over 2 is 0. So you end up with a equation here with only a in it. So that will give you, if you multiply it throughout by 2, you'll get minus 4a plus 1 minus 9a is equal to 0. So if you carry your minus 13a is 1. Sorry, 13a is 1. So a is 1 over 13. And if a is 1 over 13, b had to be minus 1 over 13. Right? Because a plus b is 0. And then c now, right? C had to be 2 over 13. Right? I remember now, we had 78 to cater for, right? Because this was 78 here. When we took the partial fraction breakdown, we had 1. So we had to multiply these values here by 78. So if you multiply 78, a by 78 here on the top, 78 over 13 is 6. Right? 78 minus 78 over 13 is minus 6. And then 78 over 13 will be 6 by 2 is 12. So hence the reason we have this 6, this minus 6, and this 12 here. So we work that back in the end then. And we have our partial fraction breakdown here now. So a over s plus 2. Right? So that is 6 into 1 over s plus 2. And your bs plus c, you could break up that into bs over s squared plus 9 plus c over s squared plus 9. And we know that the b is minus 6 into s over s squared plus 9. And we know that the c now is 12. So that is plus 12 into 1 over s squared plus 9. So this is our ys. And now we just take the Laplace inverse throughout, right? The Laplace inverse of 3 over s plus 2 is 3 e to the minus 2t. Similarly here will be 6 e to the minus 2t, and this one here will be 6 minus 6 cos 3t. And this one will be 4 12 oh, right, because it's supposed to be sorry about that. It's actually 4 because you remember this is supposed to be a 3 squared here, and then you have to have a 3 on top, right? So you have 3 over s squared plus 3 squared. And then if you have a 3 here now, you have to divide that by 3, right? So you have to divide this 3 by this 3 by the cancel, and then when you multiply by the 12, you'll get the 12 s squared plus 3 squared. So the 12 divided by 3 is 4. That is how you get the 4 here in front. So 4 sine 3t. So the final answer here is 9 e to the minus 2t minus 6 cos 3t plus 4 sine 3t. The first and second terms be combined there for t greater or equal to 0. Use the Laplace transform to solve the initial value problem. Y prime plus 2y is equal to 40. So again, we and the initial conditions here, y naught is 3. So again, we take the Laplace throughout. We get sys minus y naught plus 2ys is equal to 4 by the Laplace of t, which is 4 by 1 over s squared. So you end up with s ys minus 3 plus 2ys is 4 over s squared. You carry the minus 3 across, you have s plus 2 into ys is equal to 3 plus 4 over s squared, right? And then you divide throughout by s plus 2, so you have 3 over s plus 2 plus 4 over s squared into s plus 2. And then you use partial fraction for the second part, right? So I'm taking the partial fraction as 1 over s squared into s plus 2. Remember, I had to factor back the 4, and I had to multiply each term by 4. Eh? So the breakdown for this will be a over s plus b over s squared plus c over s plus 2. And multiplying throughout by that, s squared into s plus 2 will give me a by s into s plus 2 plus b by s plus 2. And then finally, plus c by s squared. So if I equate my coefficients now, I'll have a plus c in front of the s squared, 2a plus b in front of the s. If I collect all the coefficients accordingly, and I'll have 2b, right? So if I equate now a plus c is 0, 2a plus b is also 0, and 2b is 1. So b is a half. So if I put a half into the second equation here, right, I'll get 2a is minus a half. So a is minus a quarter. And then I put that into the first equation, c will be a quarter. And what I have to multiply each one by 4. So I have to multiply a by 4, so that will be minus 1. I have to multiply b by 4, so that will be 2. And I have to multiply c by 4, which is 1. So this is how I get my y is 3 over s plus 2 minus 1 over s, because this is my a here, plus 2 over s squared, this is my b, plus 1 over s plus 2, this is my c, right? Note 3 over s plus 2 plus 1 over s plus 2 will give me 4 over s plus 2. So these two, the first and the last term, we could combine them. And now we take the Laplace transform. So this will be 4e to the minus 2t. The Laplace transform of 1 over s is minus 1 here. And the Laplace transform of 2 over s squared is 2t. All right. Okay. So another one here, another initial value problem here, taking the Laplace transform to solve this problem. This is a second order differential equation, right? So we have y double prime plus 3y prime plus 2y is equal to 6e to the minus t. And you have your conditions here, y naught to be 1 and y prime naught to be 2. So again, if we take the Laplace on both sides, the y double prime will be s squared ys minus sy naught minus y prime naught. 3y prime will be, the Laplace of that will be 3 by, or 3 into sys minus y naught plus 2ys, and the Laplace of 6e to the minus t is 6 over s plus 1. So if we substitute the initial conditions, right, your y naught is 1, so this term here will be minus s. Your y prime naught is 2, so this will be minus 2, right? And then your y naught here is 1, so it will be minus 1 by 3, which is minus 3, right? So we just collect all the terms in ys, That will be s squared plus 3s plus 2. And the minus 2 and the minus 3 will be minus 5. Right? And the s, you carry it across, you will have positive s plus 5 plus 6 over s plus 1. And what that leads to, right? So we have to divide throughout by s squared plus 3s plus 2. So the s will be divided by s squared plus 3s plus 2. The 5 as well will be divided by s squared plus 3s plus 2. And the 6 will be divided by s plus 1 into s squared plus 3s plus 2. We know that s squared plus 3s plus 2 has two simple factors, right? So this is how we could rewrite it here. Ys is s over s plus 1, s plus 2, right? Plus 5 over s plus 1, s plus 2 plus 6 over s plus 1 squared into s plus 2, right? The first and second terms could combine, so that this will give you ys is s plus 5 over s plus 1 into s plus 2. And the second term, 6 over s plus 1 squared into s plus 2. Then the LCM here will be s plus 2, s plus 1 squared, right? So which means I'll have to multiply this s plus 5, right, by s plus 1. So I'll end up getting s squared plus 6x, and a 5 and 6 will give me 11. So this combined rational fraction is all of the ys put together. And then we use the partial fraction breakdown, a over s plus 2 plus b over s plus 1 plus c over s plus 1 squared. And multiplying throughout by the denominator on the left, you'll get s squared plus 6x plus 11 is equal to a into s plus 1 squared plus b into s plus 1 by s plus 2 plus c into s plus 2. And now it's just a matter of solving for a, b, and c. So if we let s equal minus 2, the second and the third term on the right will drop off. So you'll get minus 1 squared, which is 1. So you'll get a on the right, and then on the left here now, minus 2 squared is 4. 6 by minus 2 is 10. Sorry, 6 by minus 2 is minus 12. Right? So 4 minus 12 is how much? 4 minus 12 is what? Minus 8. Minus 8 plus 11 is 3. Right? So a is 3. If you put s to be minus 1, the first and second terms will drop off. So you'll get minus 1 plus 2 is 1. So c is equal to 1 minus 6 is minus 5, and 11 is 6. So c is 6. And then if you put s equals 0, you will end up with an equation 11 on the left, right? A plus 2b plus 2c, and then you just insert the values, so a and c respectively. So that is 3 plus 2 by 6 is 12. So 11 is equal to 3 plus 2b plus 12, right? So 2b will be minus 4, b is minus 2. So we get a, b, and c. 3 over s plus 2 minus 2 over s plus 1 plus 6 over s plus 1 squared. So the Laplace inverse of ys, yt is 3 e to the minus 2t. The Laplace inverse of minus 2 over s plus 1 is minus 2 e to the minus t. And the Laplace inverse of 6 over s plus 1 squared, you apply the shift property. Your a here is minus 1, so you have e to the minus t by t. Because 1 over s squared is t, the Laplace inverse, and you just have to take the 6 on the outside and multiply it back. So this is your Laplace, your yt, right? So look at it carefully. Use the Laplace transform to solve the initial value problem. So again, we have a second order differential equation. So this is a lot of practice here we're going through so that you'll see how to go about doing all these, carrying out all these operations. So it's just to be careful and meticulous about doing it. So you try your best not to make any errors, right? So you have y double prime plus 4y equal cos 2t's. Initial conditions here, y naught is 1 and y prime naught is 1 as well. So again, we take the Laplace of both sides, right? And on the left hand side, we'll get s squared ys minus sy naught minus y prime naught plus 4ys. And on the right hand side, you'll get s over s squared plus 4. And now you just substitute your initial conditions, s squared ys minus s minus 1 plus 4ys is equal to s over s squared plus 4. So you have here s squared plus 4 into ys, and you carry your s and your plus 1 across. So you end up with s plus 1 plus s over s squared plus 4. And then you divide throughout now by s squared plus 4. So you end up with s over s squared plus 4 on the right hand side, plus 1 over s squared plus 4, plus s over s squared plus 4 all squared. So we want to make the LCM s squared plus 4 squared. So therefore, we have to multiply the first term by s squared plus 4 and the second term 1 by s squared plus 4. So we end up here with s cubed plus 4s plus s squared plus 4 plus s. So you get s cubed plus s squared plus 5s. So the 4s and the 1s give you 5s, and then you add the 4 to it, all over s squared plus 4 squared. So this here, we could write this as a partial fraction, right? So remember, this is a quadratic factor, right? That's squared, right? But this can reduce into a simple factor. So you'll have as plus b over s squared plus 4 plus cs plus d over s squared plus 4 squared. And then the next step now is to multiply throughout. by s squared plus 4 squared. So the as plus b will multiply by s squared plus 4, and the cs plus d will cancel. The s squared plus 4 squared will cancel with it. So you'll just give back this cs plus d on the right hand side here. So your left hand side, you have s cubed plus s squared plus 5s plus 4, right? The right hand side, you equate your coefficients here. You have as cubed plus bs squared plus 4ac into s, right? Plus 4b plus d. So when you write it like that, it's really easy to see to equate your coefficients. So your coefficient on the right hand side here of s to the power 3 is a, and on the left hand side is 1. So a is 1. B will be 1 as well. The coefficient here of s here would be a 4a plus c. Coefficient of s here is 5. So 4a plus c is 5. Right? So c will be 5 minus 4a, and we know a is 1. So 5 minus 4 is 1. 4b plus d, right, will equate to the constant 4. So d will be 4 minus 4b, and b is 1, so 4 minus 4 is 0. So your d is 0, your c is 1, your b is 1, and your a is 1. So this is when you write it back here. Ys is s plus 1 over s squared plus 4, right? Plus s over s squared plus 4 squared. And this first part here could be broken into s over s squared plus 4 plus 1 over s squared plus 4. And this part here, right, done in 45.8. This is where we use the convolution theorem. So this here, the Laplace inverse of s over s squared plus 4 is cos 2t. The Laplace inverse of 1 over s squared plus 4 is a half sine 2t. And the Laplace of this here, if you refer to 45.8, is a quarter t sine 2t. So let me just go back up to 45.8. Right. This is 45.8 here. Now remember the Laplace inverse of this here, you have to multiply it by 6, right? And we end up getting this here. Right? So we catered for the 6 in front, and we got 3 over 2t sine 2t. So now if we don't have the 6 in front, we have to divide by 6. So therefore we have to divide by the 6 here. Right? So you'll get 3, and you'll get 3 into 6, 2. That is why you'll get a quarter. Right? So I'm just showing you that there. So that is why when it do have the 6 in front, you'll get a quarter t sine 2t. See, you get a quarter t sine 2t. because we didn't have the 6 in front. So don't let that little factor in there confuse you. Use Laplace transform to solve the initial value problem. Y double prime minus 2y prime plus y is equal to e to the 2t. Y naught is 0 and y prime naught is 0. Taking the Laplace of both sides to obtain the Laplace of y double prime minus 2 the Laplace of y prime plus the Laplace of y is equal to the Laplace of e to the 2t. So you get s squared ys minus sy naught minus y prime naught minus 2 into sys minus y naught plus ys is equal to 1 over s minus 2. And then when you substitute the initial condition, the second, right, this term here, you're substituting 0 here, so this will drop out, this will drop out, right? This here will drop out as well, right? So just get y s squared ys minus 2s ys plus ys is 1 over s minus 2. And then you'll factor the s squared minus 2s plus 1 into ys is equal to 1 over s minus 2. So ys will be 1 over s squared minus 2s plus 1 into s minus 2. And this could be factorized into s minus 1 squared into s minus 2. So you have a simple repeated factor and a simple factor, so that will give you 1 over s minus 1 squared into s minus 2 as a over s minus 1 plus b over s minus 1 squared plus c over s minus 2. And just the rest here is just straightforward solving for a, b, and c. So for a, you get minus 1, for b, you get minus 1, and for c, you get 1. So the Laplace inverse of 1 over s minus 2 is to the 2t minus 1 over s minus 1. The Laplace inverse of that is e to the t. And then you use the shift property here now, 1 over s squared minus 1. So your shift here now is plus 1, right? So you get minus t e to the t for t greater or equal to 0. Right? So I just wanted to okay, so let me just come back now to you. Right, so I want to do a little talking now. So I'll stop there in terms of going through the tutorial with all those questions. So we will continue the lecture again on Friday, but I want to talk to you about the midterm now. So I'm thinking about having the midterm 2 Wednesdays from today, which is right. Today is the 22nd, so that will be the 6th of July. So the 6th of July is the tentative date. Now, on that date, right, the midterm, as you are aware, would be it will be online, right? So it will be in my e-learning. So our exams similar to what you did the last time, the same type of format, the same kind of questions, right? Where you have like multiple choice responses, you have a question with like 2 or 3 parts, right, on a differential equation, and you have to find the Laplace, you have to find the you had to break up the right-hand side into into a combination of heavy-side functions, right? And find the Laplace of it, right? And things like that, periodic functions, right? Similar, very similar to what you did last time, right? Last semester, the same type of format, right? So I'm asking now if next 2 weeks Wednesday, because this is sufficient notice, if that date is a good date for you, and the exam will be the same time period between 10 and 12, right? The same class time. So when is 10 o'clock you log in, and the exam closes off at 12. So you have to make sure and complete it within that 2-hour time frame, right? So anybody have anything to say? If we don't have it the Wednesday, we could have it the Friday, right? So if you want, in those two days and those 2 time periods, if those time periods are suitable for you, because the time periods are actually your class time. So in any case, you're supposed to be in class. Is the Wednesday a good time? Anybody? 10 to 12 on the 6th. Right, so I see somebody say yes, right? So let me just see by responses in terms of like in the chat, if you agree with the Wednesday 10 to 12. I see 3 people so far responded. Four. All right, somebody saying no, but let me see. All right, let me see the rest of the people. All right, so some saying so actually that Friday could be the, if we have any the Friday is the 8th. That Friday will most likely be the last day, right? So that will be just about 10 days before your final exam. I mean, it's not a problem. You'll have more time to prepare, right? So is that okay with everyone if we have it Friday? Right, so some people say, right, so we can't have a stalemate where it's either Wednesday or Friday. It had to be one or the other, you know? So if it's the Friday, it will be from 1 to 3. If it's the Wednesday, from 10 to 12. That is the time you'll go into the classroom and do it. All right. I'm just looking at the responses here to see. 1, 2, 3. So I looking at I'll have to kind of make a decision here, regardless of what you all are, some saying Wednesday, some saying Friday. What about those who saying Wednesday? They could do the Friday, but one person saying Wednesday is difficult for them. Right? So whatever you're doing, you'll have to make arrangements to have yourself available on whatever the exam is, right? So, okay, I will have it the Friday, right? So that is the Friday, the 8th, right? So if for whatever reason you had some kind of engagement or something to do on that particular day, try to make arrangements to be available to have the exam, in order for you to do the exam rather on that particular day and time. So Friday, the 8th from 1 to 3. So that is the time it will open in e-classroom, right? Remember the format, same type of questions, multiple choice, numeric responses and so on, right? So some questions might have like parts, like 2 parts, 3 parts as the case may be, right? And the format is similar to what you did last semester. So you could use what you did last semester as a guide, and you could also go through all that we did so far in terms of the questions, because it would be things like you will have a second order differential equation, and you have to find the Laplace inverse, right? You might have to find the limit of a function to see if the function converges, and what the limit is if it doesn't converge, it diverges, or something to that nature, right? Piecewise functions defined within our region, break it up into a combination of Heaviside functions and so on. So questions to that nature. So that is basically what you had to do. So all that we did so far up to page 67, I want you to really review it, go through the problems that we went through in the Finan, right? Make sure you revisit them. I try to write all the solutions as more in depth than it's written in the text. And what I'll do, I'll try to put it up in e-classroom. So I'll put up the solutions that I wrote in e-classroom, so you could go there and you could find it, right? Because by now everybody's enrolled in e-classroom, so they could go there and they could do whatever. See the videos and the URL link to the YouTube videos, right? So
actually, sir, I still haven't been registered. Like I've emailed the respective people. I told my other lecturers and stuff. They say that they would tell the respective people to like manually register, man. I still don't have access to maths and programming course on my learning summer courses.
I seen Lisa Ali. That
is Isa
huh?
Ali.
Isa Ali.
Yeah.
All right. So you're not seeing it when you're going to my e-learning?
No.
All right. So write your student contact for me now. Let me see if I could you're calling IT and asking them about it.
They had given us somebody to email. I emailed that person and they said that they would organize. That was like a week ago.
All right. So let me see. Write in your student information, like your email and so on there for me. Student ID and email. So you could put that in the chat there now. Let me see if I can write it down.
All right.
So the test is, the midterm is on the Friday, Friday the 8th from 1 to 3.
Yes.
Right, so a senior ID. Right. Right, so I have your ID, your name and your email address, right?
Yes, sir.
Right, so I'll check and see if I can manually enroll you. And
Yes,
if
so
I
that'll
can
be
manually enroll you, then I have to send the information and to the program coordinator and let them know what's taking place, because you will have to be enrolled before the time of the midterm, because you need to
yes,
do the
sir.
midterm, right?
Exactly, sir. But I
Yeah.
told them a while ago now. I mean, is what
In
2.5 weeks now.
collaboration with me, try to make contact with them again, probe them, and I will probe them and see,
Yes,
right?
sir.
If we can rectify it within the next day or two.
For sure.
How about the
If any,
access to the material and so on, like the YouTube video where it's public so you could see it on YouTube,
yeah, they
right?
just
So
be
you'll
sending
get
it on the WhatsApp chat. So that's good.
I could always
Okay.
email you the solutions, right? So I could email you the solutions if they don't rectify it within a day or two, right? So try to
Okay,
do
sir.
that.
Yeah. Thank you, sir.
All right then. So if anybody else who have any questions, we could end there, right? So I'll see you all on Friday again when we will continue going through the direct delta function and all the other stuff in the notes that wouldn't come in the midterm, but will come definitely in the final exam. So I'll see you on Friday. Take care, right?
Yes, sir.
All right. Then.